Here we are. Welcome, everyone, to How New York Farmers Are Saving Big with Geothermal Heating and Cooling. I'm Ron Kamen, your host. With us today is Michael Murphy and Suzanne Hunt, and we'll be hearing from them in just a moment. But first, we'd like to start with why. Why is this important? Well, the number of natural disasters from the disruption of the climate is increasing dramatically, and farmers are taking the hit in a massive way. You guys have hit $6.5 billion in crop disasters alone in 2020, more in 2021, and less than half of that is being covered through various different USDA risk management reimbursements. So first, it's a big financial hit for you guys. It's obviously on struggling family farms in particular. It's dramatic. And then, because of all the flooding and everything here in the Northeast, what we're seeing is 20 million acres in 2019 weren't able to be planted because of rainfall and flooding. And now in 2020 and 2021, that number has gotten even worse. The amount of energy trapped by carbon and greenhouse gases is equivalent to 500,000 nuclear weapons being exploded every day, 365 days a year. And why that's important is because basically, as all this energy happens, we're literally changing the climate, we're changing the weather, we're changing the jet streams. By the jet streams becoming more wavier and wobbly and less certain, what's happening is we're seeing longer duration and more extreme weather events, things like droughts, floods, heat waves, wildfires in the Northeast, here in the Northwest, here in the Northeast. Obviously, we're seeing tons of floods and extreme weather events that way. And as this happens, what we see is a dramatic increase in the amount of weather catastrophes and the cost of those catastrophes. So it's not just farmers, it's really everyone that's taking the hit. And the federal government has documented that on the average now, we're seeing better than one a month in terms of billion-dollar disasters from extreme weather events. It was almost 2 a month, with 22 in 2020. That was a cost of nearly $2 trillion for the disasters that they've been tracking since 1980. In 2021, we've already seen 18 $1 billion weather disasters happening across the country. And of course, the last one that most of us experienced, which cost $60 billion, which was the fifth most costliest hurricane in the United States, Hurricane Ida. Scientists have now documented that the number of 1 in 1,000 year downpour events since 2010, you know how many of those were? 18. So 1 in 1,000 year of downpours, but now happening 18 times since 2010. And when we take a look at the risk of having additional sandy intensity type of events, 100 or so years ago, that was like 1 in 500 years. As of 2017, that increased to 1 in 25 years. And now, within the next couple of years, we're looking at a sandy type of intensity event that's going to hit everybody once in every 5 years is the risk analysis. Climate change is also a medical emergency, as is really documented very well. Worldwide air pollution is killing over 9 million people a year. But in addition to disrupting, our lungs and everybody that we know that has asthma and other respiratory illnesses, what we're seeing is that it means massive dislocation of people. We talk about immigrants and the need for migrants to move, and there's going to be projected over 1 billion climate migrants in the world. And the main reason they're moving is because they don't have anything to eat. So you farmers, as you know, are critical to our livelihood, to our ability to survive. And these technologies are now becoming more and more critical. And it's a way for you to have an impact and save money and have the ability to keep going. So I'm Ron Kamen. I'm your host. I've got 30 years of clean energy experience. I've been in clean energy for over 30 years. I've done a bunch of different things with the solar energy industries, with the US EPA, with clients, with awards. I've been parts of various different councils and business associations, including the Environmental Entrepreneurs, which are 10,000 entrepreneurs across the country that work to ensure that people understand that it's not the economy or the environment. They go very well hand in hand. And as a matter of fact, when the environment's out of whack, it disrupts the economy, as we're seeing with these massive extreme weather events. I've worked with a lot of different clients over the years, public, private, small, large, some folks that you'll know in the government sector from a number of different years, folks in the nonprofit sector, and then also businesses, everyone from small businesses through large entities. And my goal is always to help people figure out how to reduce their carbon footprints, but save money doing it. And by doing so, we can become totally sustainable. When we take a look in New York State, what we have to identify and realize is that most of our greenhouse gases come from our use of energy, and that energy is in three forms. It's what the electricity that we consume for all our electric usage, but then it's also heating and cooling our buildings, and it's transportation. And when you look at that, it's almost a one-to-one comparison between how much money we're spending on electricity, heating, cooling, and transportation, and the amount of greenhouse gases. So every bill that we get is really tied to the amount of greenhouse gases we're producing. And when we take a look now, New York State has passed in 2019 the Climate Leadership and Community Protection Act, or the CLCPA. And this is now a mandated law that has a goal of reducing carbon by greenhouse gases by 40% by 2030 and 85% by 2050. And the way that we're going to accomplish that with electricity is going from 25% clean electricity today to 70% by 2030 and 100% by 2040. And that clean electricity is then also going to power clean heating and cooling solutions, as well as transportation. The thing to recognize today is that the way that we're accomplishing our goals right now in New York State is having about $5 billion worth of incentives. These are grants for everything from solar at $1.5 billion through clean heating and cooling technologies, including geothermal heating and cooling, and then electric vehicles and charging stations, another $650 million. On top of that, there are tax credits that are available and can be taken advantage of if you're in a taxable situation, plus low interest financing, plus often energy as a service where third parties will put up the capital, take those tax advantages and incentives, and then just give you that energy, sell you that energy as a service over time at a reduced rate compared to your standard energy cost. The other piece to recognize is that very soon there will be penalties where if we don't do this voluntarily and take advantage of the incentives and have a good return on our investments, what's going to happen is what's happening already in New York City with the local law 97, where everyone who has a building over 25,000 square feet has to meet certain carbon reduction goals by 2024. Otherwise, they start paying penalties. Around New York State, there's the Climate Leadership Task Force, which is working on how New York State is going to achieve these goals. Right now, it's incentives. Very soon, it's going to be changes in code. So every new building is going to have to be constructed with a net zero energy impact, greenhouse gas impact. And the same is going to then come true for all our buildings and our transportation and our electricity, where we're going to have carbon emission limits. And those penalties will be substantial. In New York City, starting in 2024, they're 50 cents a square foot for buildings, and then it goes up from there. You may have heard about the solar programs, as we mentioned before, and if you haven't taken advantage of solar yet, you really should think about it, because right now we're in the second to last tranche. These were all tranches that got filled with a certain level of incentives. For upstate residential, we're in the second to last tranche. It's just about to go into the last tranche. Upstate non-residential, which would be many of your farms and other types of businesses, we're also in the second to last tranche. We've got a little bit more to go there, but get in soon. And then in terms of community solar, which is another piece, this commercial aspect, that is now filled. Once these tranches get filled, which is what happened in Long Island already, there is expected that there will not be any more cash upfront incentives for solar. So take advantage of the incentives now, or have to do it without incentives later, or get hit with penalties ultimately for not achieving your goals. Today, as we mentioned, we're going to have a raffle of the delicious Hunt Country Vineyards wine, the Uncharted Terroir, which Suzanne will talk about in a little bit, as well as the novelty organically grown wines, and that'll be at the end. And again, for everybody that's put your intro into the chat and or stays till the end, you'll get an extra shot at the raffle that we're going to roll for everybody who's here and has registered for today. And with that, I'm going to leave it to pass over to Suzanne. If you would take it from here, Suzanne. Thanks so much.
Sure, Ron, let me pull up the slides here. Why are they not showing? Murphy's Law, here we go. All right, can you see them now?
Yes.
All right, and can you hear me okay?
Hear you great. Thanks so much.
All righty. Thanks for the invitation, Ron. Hunt Country Vineyards is my family's 7th generation farm and winery. My parents started the winery 40 years ago. It's our 40th anniversary this year. I moved back to the farm, grew up here, and then moved back about 6.5 years ago already. Time flies when you're having fun. But I wear 2 different hats. I am also the, interesting, well, let me advance. There we go. I am also the, in addition to being a co-owner and helping to run the winery and the farm, I'm also the director of policy for the upcycle division of Generate Capital, which is a company that finances green infrastructure. So I wear a couple different hats. I've worked with, much like Ron, I've worked with lots and lots of different stakeholders in the clean technology and sustainable agriculture space over the years. So I bring that to these conversations as well. You know, and a lot of these issues get super complex and super involved, but at its core as farmers, really, we're just trying to take care of our air, our water, our soil, and maintain a stable climate so that we can keep growing food and in our case, also wine. I think Ron did a good job of giving an overview of just how urgent the climate situation is. It's not just extreme disasters that are affecting farmers. It's also just the steady warming, the kind of steady changes that are happening, as well as these sort of highly variable experiences that we're having. So just last weekend, we had flooding here again this year, but also the wine regions of the world, you know, wine grapes being one of the most climate sensitive crops there is. The wine regions of the world are starting to shift because of gradual warming, because of sea level rise. The wine industry is already having to adapt and change trellising systems and a whole bunch of viticultural practices already because of climate change. That's impacting us in New York with, on average, warmer winters, but as Ron mentioned, that destabilization of the polar vortex air is also causing incredibly extreme winter temperatures in 2014 and 2015. We've had droughts and then we've had floods. So it also brings new pests, and it just makes it more expensive, more labor intensive, and more difficult to grow food and everything else that we need. So one of the key messages that I try to get out in general when I'm talking about sustainability generally to folks is resilience through diversity. That principle also, you know, applies in our energy system as well as our food system. You know, one of the nice things about the Finger Lakes wine region is that we do have quite a diverse variety of grapes, and we have a number of grapes that have come out of local breeding efforts, especially at Cornell, to adapt grape varieties to grow well through challenging growing conditions. So regionally adapted grape varieties, those are some of the wines that Mike and Ron are going to raffle off from us, or some of the wines that we are making from some of these rugged regionally adapted varieties. That's our Uncharted Terroir line. But we also need diversity and resilience in our energy systems, which is why we have nearly fully eliminated our fossil fuels for heating, cooling, and electricity at our operation. It's interesting how quickly prices have been going down. If you haven't checked in a few years, It's worth rechecking on prices. I don't remember how long. It was a long time ago. We looked at replacing these old inefficient lights here on the left with LEDs. And at the time, it was going to cost something like $1,000 per fixture. And then when we did go through and replace all of our light fixtures, hundreds and hundreds and hundreds of them, these huge ones to replace these LEDs on the right, I think were $80 per fixture. So, the prices of solar are going way, way, way down really fast. The price of LEDs, a lot of the technologies needed are changing, are going down really fast. And then, as Ron mentioned, there's lots of different ways to finance these investments. I'll skip through pretty quickly. I don't, Ron, give me a warning when I'm halfway through my time. We've experimented with a number of different technologies, not just, geothermal, and also there was a big conflict going on over wind in our area, maybe 12, I guess it was about, over 12 years ago. So we put up this little prototype vertical axis wind turbine just to demonstrate that these technologies come in all shapes and sizes. It was in 2012 that we installed a large geothermal closed loop system. We can talk about this more later, but it has been heating and cooling all of the large buildings here ever since. And it was a complete godsend during the polar vortex winters. We knew a lot of folks and a lot of businesses that had unexpected enormous heating fuel cost increases those years that we didn't experience because we had the heat pumps and they were working a little bit harder, but we didn't have to buy a huge amount more combustible fuels that year. So that was a huge benefit of the system to us. In addition to now that it's paid for, we're saving probably, on the order of $10,000 a year in heating fuel that we no longer need. We use more electricity, but it's a lot less expensive than the heating oil would have been. This was the drilling rig that came in. It was Moravik that came and drilled the borehole. It's about 6,000 feet of piping. It's all a closed loop. It's 8 boreholes and they go down. Each one goes down about 375 feet. And again, we can circle back to this if folks have specific questions at the end. I guess it was 2015, we put in 348 solar panels. We chose to put them on the roofs because the panels have no moving parts and require no maintenance, and they last for decades. And who knows what we're going to need a given field for in 10 years, let alone 20 or 30. So we chose to put the panels on all of the roofs, so they're just out of the way. 2 years ago, we were able to install 5 electric vehicle chargers in our parking lot, and we provide free charging to our customers during business hours. Transportation is one of the trickiest sectors. We are working on it. We've got a little electric gator. We've got some electric cars in the family, but no electric tractors available quite yet. You can put down payments on them, but I don't think there's any that we can actually get yet. Still waiting for them to be affordable, practical, and available. Ron just cut me off when you want me to get back to energy, but you had asked me to give a little bit broader overview. So I'll just touch on a few things we're doing. We're always trying to reduce waste. Every business, every farm is trying to reduce waste. It dawned on us a few years ago that the plastic capsules or the foil capsules on the bottles were just decorative. They don't serve an important functional role when you have a cork closure. So we stopped using them and we've gotten exactly 0 complaints from customers. I think the bottles look cleaner and sleeker without the capsule. And it turns out no one likes them anyway. So a lot of these investments, save you time and money, but also hopefully make the customer or user experience better as well. We made some lemonade out of lemons when we were shut down for 3 months for the pandemic. We worked with the Interface flooring company and put in sustainable flooring in our visitor center and tasting room. They make a number of different floorings from sustainable materials, but this one in particular was fully made from fully recycled materials, and it was able to be put on top of the old flooring, and at the end of life we can remove it and it's fully recyclable again at the end of life. So 0 waste to landfill. I think one of the most important things we do is a business is use our voice and work industry wide. Individual farms and individual businesses can only do so much, but as an entire industry, we can do a lot, and we can work with our adjacent industries, adjacent packaging, whether it's packaging or fertilizer or whatever other adjacent and kind of codependent industries that we work with. When we team up, we can have pretty big impacts. So we helped other wineries go solar. We worked with banks and local financing institutes to help a number of wineries go solar. And then most recently, we've joined the International Wineries for Climate Action organization, where a number of wineries around the world are committing to reduce emissions. We're having them audited by certified auditors, and then we're ratcheting down our greenhouse gas emissions as an industry, scope 1, 2, and 3 emissions over time.
Great, Suzanne. Thank you so much. You want to just conclude real quick, or?
Yeah. So I'll skip all of the actual farming practices stuff and hand it back over to you guys and hand it to Mike to talk specifically about geothermal.
All right, Suzanne Hunt from Hunt Country Vineyards. We're going to take questions at the end. If you folks would put them into the Q&A, that'd be great. We've got a couple of questions that we'll be handling back in a bit. But for now, I'd like to pass it over to Michael Murphy. Mr. Murphy, if you would be so kind. Mike Murphy's been involved in the HVAC industry for over 40 years. He's been involved with geothermal since 2015 or longer, actually. I think it was longer than that. Sorry about that. I think it was 2005. And there was a typo in your piece there. Sorry, Mike. Mike is also a continuing education provider. He does continuing education classes for the AIA, the Architects Association. And Mike's going to give us some background and deal with some of the technical aspects of geothermal. So if you would, Mike, please take it away. Thanks so much.
And you can see my screen and hear me all right?
Yes, sir.
Perfect. Thank you all for coming. I certainly applaud the efforts of Suzanne and her crowd in their efforts to reduce their carbon footprint. And that's pretty much what my discussion is today, is how to get that 32%, 34% of load on the energy grid relating to heating and cooling structure down using geothermal heat pumps. I really like to say that this technology is unlike the solar panels or the wind turbines, in that you can't see it. Once the ground loop gets covered up, as you see there in the squiggly lines beside that farmhouse down there in Blackstone, Virginia, you don't know that a home has a renewable energy power plant in their house. The United States government, federal government, does recognize geothermal heat pumps as a renewable energy, and thus has available to it the incentives, if you will, that are attributable to all renewables, such as wind and solar. We'll get into that a little bit at the end further. And it is a technology that can function in extremely hot climates as well as extremely cold climates. I moved from the Midwest, or the cold Midwest, where homeowners and business owners felt that geothermal heat pumps were a Southern technology. And I presently live in Georgia, where many homeowners and business owners perceive that the geothermal heat pump is best in colder temperature climates. The fact is that we are a very high efficient renewable energy in all climates. And it's certainly a scalable technology. We can heat, cool, and provide hot water for 900 square foot Habitat for Humanity homes, all the way through large buildings such as the Oklahoma State Capitol building with 600 heat pumps on a ground loop, or Ball State University, which is probably the largest geothermal ground array in the country. It's also a very flexible technology in that we can use it to heat air, we can use it to heat flooring, as well as use the same piece of equipment to provide air conditioning. And it's also a technology that we can use in many different applications, from cooling milk in the dairy farms to used in the process of turning the grapes into wine. It is only limited by your imagination as an engineer as to how this technology can be used. And the Environmental Protection Agency said quite a while ago that geothermal heat pumps are the most energy efficient, environmentally clean, and cost-effective system for heating and cooling the building. And it is all focused around the sun. And the sun, in conjunction with the earth, provides the energy that we use to condition structures. In the slide that I'm showing now, you see heat generated by our sun being absorbed into the earth, and that is most of the heat, 46% of it. And it keeps the ground temperature in certain latitudes around the United States and the world at temperature. And you see in New York, we're somewhere in the vicinity of 40 to 50 degree ground temperature. Well, we use heat pump technology to take that 50 degree earth temperature and extract some more heat from the earth, as well as accept rejected heat from a building in the cooling mode. And that earth temperature remains stable, the same all year long, whether you are in southern Florida at about 77 degrees, or whether you're in the northern Yukon at 42 degrees, it stays stable. So most of you are familiar with air source heat pumps. They extract heat from outdoor ambient air and move it into a structure, or they take it from a home or a building and put it into the outdoor ambient air. The concern we have with air source heat pumps is when they are supposed to be the most efficient on your 95 degree day or your 5 degree day, they are least efficient. We don't suffer from that malady in that we have a constant temperature at earth all year long. So we are using water, or in the case of New York, water mixed with antifreeze, and we circulate that using our geothermal heat pump through a series of buried pipes in the ground to extract or reject heat. We are the only renewable energy that uses electricity, but we sip it rather than drink it. If you buy a kilowatt of energy from the utility or from your solar array, you use that kilowatt of power to fire off a compressor and a motor, maybe if that's the style that you're using to condition the space. And we transfer heat, 3 to 5 kilowatts of it from the earth into the structure. And that energy, or BTUs or heat, is essentially free. So we effectively deliver to the structure 4 to 6 kilowatts of energy for the 1 kilowatt that we purchase. That makes this technology 600% efficient. Because we move heat, we don't make heat. And we do this through a series of buried pipes, high density polyethylene tubing, with life expectancies that are unknown at this point, from the standpoint of we haven't had any of them degrade to the point where they're going away yet. There's plenty of high density polyethylene pieces in landfills that are going to be there. So this is a very robust product that will stay in the ground, certainly for the life of the structure itself. And we have 4 basically designed ground loops that we use. One of them Suzanne has already alluded to because they use that in their winery, and that is a vertical system. And we will determine how many linear feet of borehole are needed to extract heat or reject heat of sufficient quantities to condition a space. And we drill that many linear feet of borehole. You see from my slide that the boreholes can range in depth from 150 to 400 feet, and even deeper if the drilling contractor has the equipment necessary to go deeper than 400, down maybe through 600, or even deeper than that. Because farms generally have real estate associated with them, horizontal trenching is a popular ground loop for that type of application. We would bury a series of pipes 5 to 6 feet down in a 3-foot wide trench and put a predetermined amount of piping in that space. A very effective ground loop in all areas of the United States will be a pond loop. We love our pond loops to freeze over on top. That keeps the water beneath it at approximately 39 degrees, which using heat pump technology can make that heat pump extremely efficient. And finally, on the right there, dependent upon the municipality that the property is located in, we may have the opportunity to use well water to run through a geothermal heat pump system, give that water temperature in the cooling mode, and then discharge it back into the aquifer and continually cycle water through a heat pump, extracting or rejecting heat from it. A couple of photos here to bring what I've just described in pictures a little clearer into focus. On the top right, we've got 3 circuits of supply and return piping in a 3-foot wide trench. And we all, manufacturers, have software that would tell us, based on the number of BTUs that we need to condition the space, we need this many linear feet of trench with 3 pipes, 3 circuits in it to extract or reject the amount of heat with that load on the building. On the top left, I believe this is Juneau Airport. We are using a geothermal system to condition the terminals in that airport. On the bottom right, we've got 1 ton of conditioning, or 1 ton of capacity per coil that you see in that frame. And if you count up real quick, there are 14 tons of capacity in that frame in the center of the picture. And I will say that this particular application on a 12-acre lake in Wisconsin, they have 1,500 tons of cooling capacity in the building that lake loop is sunk into. So if a lake is on a farm property and it's within a reasonable distance from the structure we are trying to condition, we may look at the lake as being the least expensive ground loop that would fit onto that property. And I do get questions frequently, what is the best ground loop to install for efficiency levels? And an accurate, good answer would be the one that rejects the amount of heat or extracts the amount of heat, depending on whether it's a heating dominant climate like New York or a cooling dominant climate like Southeast Georgia, the one that fits the space for the least amount of money. And that ground loop is what we will consider the best ground loop to fit into that geothermal heat pump. A picture here of what goes down a vertical borehole. And we can also use this factory pipe in horizontal trenching as well. But the pipe really doesn't want to go down most boreholes, so it is tested and filled with water. And we send that pipe, that coil of pipe, down to the bottom of a drilled borehole. And then we fill that borehole with bentonite mud. It's also called grout. And that grout mud will swell and seal the pipe to the surrounding geology. It's done for a couple of reasons. All manufacturers pretty much say, don't drill a borehole, put a pipe in it without grouting it. But it is done to both give us good contact between the solution-filled pipe and the surrounding earth, as well as seal any aquifers that we drilled through as that drill stem went down 400 feet. We don't want aquifers that don't have the same quality of water in there to commingle. So we will put this bentonite mud in the hole so that those aquifers are sealed from talking to one another or commingling. Farmers have the biggest hurdle overcome usually already, and that is real estate. This is a picture of a friend's farm ranch out in Oklahoma, and he has just rolled an awful lot of hay for his horses and cattle, and he has a perfect opportunity at that point, once he gets rid of his hay, to install a series of horizontal pipe in the ground. And one season later, no one will know that Lloyd is using a geothermal system to heat his home in one of the harshest design areas that I have seen, being around Tulsa, Oklahoma. It does give the farmer options as to what loop field they select as being the least expensive. Most farmers that I know either own a track hoe, a backhoe as they do their farming work, and would prefer to dig the trench themselves, or they have a friend that lives down the road that would be able to do that for them. At that point, a load calculation is done on the parts of the farm that we're going to be conditioning, and the farmer is then told, this is how many linear feet of trench we need to put into the ground to support the load of the tasting room, the birthing room for the pigs or the chickens. So once they have determined what we need, then we determine how much trench we need to dig, or a borehole that we need to drill, or pond coils that we need to sink. But farmers do have the biggest hurdle already behind them. Now, this is good. This technology is good for the livestock. Dairy cattle are much happier and produce more product when they are moderately heated rather than extremely cold temperatures that you would see in places like New York and Pennsylvania and Oklahoma. So very frequently, farmers will use radiant floor heating in different spots of their facility in order to keep the temperature moderated. Now, I'm not saying they're going to heat it to 72 degrees, but certainly cattle, chickens, pigs are much happier at 35 degrees than they would be at -5 degrees. The photo on the top left will show a larger diameter, high density polyethylene pipe loaded into a trench that has been dug by a rather large piece of equipment. But, as long as we bury that pipe in a safe trench and we know how many linear feet we need of it, we will extract or reject the heat necessary to condition the space. Not only is this technology good for the livestock, but it's good for the farmer. They do seek ways to make their processes more energy efficient, and geothermal heat pumps enable them to do that. Geothermal heat pumps, in conjunction with the use of solar even further. So it also, I have put down several ways that farming is using our technology, and another of them is to heat and condition greenhouses so that they can raise flowers, crops throughout a cold winter through geothermal technology. We've got several different types of equipment that are used, meaning pieces of equipment that would heat air, pieces of equipment that would heat or cool water to space condition darn near any facility. Residential and commercial tax incentives. NYSERDA, the New York Energy and Research Authority, has certainly come to the solution of we need to be as energy efficient as we can with about the largest user of power to condition spaces, and that is buildings. And we need to do our darndest to reduce the carbon that we generate when we do space condition. So using electricity rather than burning a fossil fuel is the only way that we as a world will reach our carbon reduction goals and be far friendlier to the earth as we move into the next millennium. So eliminating the volatility of the pricing of fossil fuels is key to all of us, homeowners and business owners, farmers alike. I remember when we first got into this technology, it was even before 2005 for me. There were no incentives to embrace this technology, but the price of natural gas at that juncture was very high, as was the price of propane and fuel oil. As this technology unfolded and as we moved forward from those earlier days, the cost of natural gas became a little bit lower, and therefore the comparison operationally of geothermal heat pumps to natural gas was not quite as beneficial for building owners and homeowners. We're going the other direction again. We are seeing that fossil fuel prices appear to be rising, and the recognition of what the byproducts of fossil fuel are is becoming more apparent through global warming. So it is time to truly embrace renewables and the geothermal renewable as a potential solution for all heating and cooling issues. Leading into it's good for the environment. So we have seen that in the farming application, this technology is good for the livestock, it's good for the farmer, good for the environment. The use of a single geothermal heat pump system, its carbon emissions elimination or dramatic reduction is the equivalent of planting an acre of trees and taking a couple of automobiles off the road with the combustion byproducts that are generated with an automobile. So it is a technology that is good for everybody, and the utilities like it for several reasons. One of them is it enables them to have better control of their peak demands, both summer and winter. And that is an area that costs all of us a lot of money when it gets very hot and very cold. The utility must have kWs available to you or energy available to you. And very frequently they have to go out on the open market. They've contracted for a certain usage and they use a lot more because it got very cold or very hot. they have to go out and buy it. The use of a very high efficient geothermal heat pump enables them to manage their loads much easier and friendlier. So geothermal heat pumps is simple, but it's proven as an alternative to fossil fuel in space conditioning in most applications. Here is my contact information. I will be happy to steer you in the direction of folks in New York that can assist you in designing as well as installing systems for your home, your tasting rooms, your pig birthing rooms, any application that we heat with fossil fuels, we will be able to condition with a geothermal heat pump. So at that point, I will stop and we'll take any questions, turn it back over to Ron to facilitate any questions that you may have. And thank you.
All right. Thanks so much, Michael. Really appreciate it. It was a great job. Thank you, Suzanne. Okay, we got a couple of questions, folks. If you would please put your questions into the Q&A section. Then we will answer those, and everybody that asks a question actually gets another chance at the wine. So just FYI, another reason to please share if you'd be so kind. This is the contact information. Please take it down. I'm going to stop sharing the screen now. We'll put this back in a moment. But in the meantime, if you would, please, let's see, Suzanne, first question for you. So when you guys were looking at geothermal and you were evaluating, what were you previously heating with, and what did you find were the benefits of moving to the geothermal system?
Yeah, so my dad, Art Hunt, actually spearheaded the geothermal project before I moved home. So I just want to give my dad some props. And one of the biggest benefits, in addition to what I mentioned before, in terms of electricity prices are much more stable, and the system's just so much more efficient. As Mike was saying, instead of creating heat through combustion, you're just moving heat around. So the cost savings have been important. But also, because we're a 7th generation farm, we have some very, very old buildings that we've retrofitted. And then we also have some new buildings. And so in the old buildings, they're smart enough to build them into the sides of hills, so you get some natural geothermal cooling, but none of the buildings had full cooling systems. So the geothermal was installed in large part to provide the heating, but also had the co-benefit of having cooling for when we have super hot days. So that's been nice. And then let's see, we are on the winery side and the tasting room, we're a hospitality business, and the heat pumps are essentially silent. So compared to a combustion system that are kind of can be pretty noisy, that's also, I think, quite a benefit for hospitality and just comfort, just the quietness of these systems.
Yeah, excellent. Thanks so much. I mean, one of the benefits that many people say with geothermal is that you have a constant temperature, as opposed to with a thermal system or a regular air conditioner. It comes on, it goes off, it comes on, it goes off. You get hot spots, you get cold spots. But with the geothermal, since it's most efficient, running pretty much at a constant time, you get much more consistent temperature and comfort. Is that something that you guys found?
Yeah, I think so. I think that's I think the temperature in the buildings is much more consistent now. And yeah, and I really appreciate not having the loud combustion systems where they kind of like go, they turn on and make all that noise. And so, yeah, I mean, it's any businesses trying, and especially in agriculture, we have, a lot of labor shortages in a lot of industries nowadays. And so anything we can do to make our team more comfortable is a big bonus.
Excellent. Outstanding. Mike, a couple questions for you. One was, how do you wind up sizing how long the pipe run is or how deep the wells are? And then what are the warranties on either the pipes and or the other equipment?
The load of the structure is key in a successful installation for geothermal. So we need to find out, generally through an ACA manual J load calculation, and picking a design day of, let's say, 5 degrees in New York, and determining how many BTUs do we need to put back into the structure in order to heat it to a temperature that is dictated to us by the building owner or the farmer. And that will, using software that all manufacturers have, and there are some independent providers of ground loop design that are very accurate, using the geology that we have in a specific area, determining how much heat that geology can accept on a cooling cycle, or would yank out of the ground on the heating side, and we put enough pipe into the ground, whether it is vertical, horizontal, pond, to satisfy the thermostat at the design temperature. So what happens when it goes below the design temperature of 5 degrees? Most geothermal installations will have some supplemental heat in the form of electric heat strips. Unfortunately, though, those are 100% efficient. For every kW that you buy off the grid, you get a kW of heat. However, the geothermal heat pump at 400, 500% efficient continues to provide most of the heat, and that supplemental heat on the very brutal days is used to condition the space to the design temperature. So you're not spending any money as a homeowner, as a business owner, as a farmer, when you are designing something. And the success of any installation, particularly a geothermal heat pump, is predicated upon good, sound designs. And that involves consciously choosing the linear feet of borehole, of trench that is needed to supply the structure of the necessary heat.
Great. And the warranties,
there-
Mike, on the whole, on the pipe or indoor on the other equipment?
Yeah, the pipe, there are several manufacturers of high density polyethylene tubing. It, by the way, is the same tubing that the natural gas industry uses to transport their product through the ground. It is warranted by some manufacturers against defects for 50 years, and others are 100 years. But I feel fairly strongly that that pipe isn't going to degrade through our lifetime or the lifetime of our children, grandchildren, great-great-grandchildren. You may change equipment over the course of years, but the heat exchanger, if you will, the power plant will stay undisturbed for a couple of lifetimes. Warranties. Residential product for most manufacturers will be in the vicinity of 5 to 10 years. On the residential side for homes and applications in industry or in commercial. And then on the commercial product, that would be the larger product used in, for whatever reason, larger product. The warranty on that generally is out of the factory at a year with the option of purchasing additional 5 years of parts. Most manufacturers have it set up that way.
Excellent. Thanks so
Two
much.
different warranties, one residential, one commercial.
Thank you so much, Mike. Really appreciate it. So we're at the time that you've all been waiting for, which, if you do have additional questions, please feel free, drop them to Suzanne, Mike, or me in an email. So just take down these email addresses and we'll send out contact info at the end of this as well. But if you have any additional questions, let us know. Happy to answer all of them. And then the part that you've all been waiting for, as we know, is the chance to win the wine. So here we go. First one will be the Uncharted Terroir Cayuga White. And we're going to spin the magic wheel now, and let's see who is going to win. And the winner is Bill M. And Bill, if you would, woo! Drop an email, just drop into the chat function. Let us know your email. I think we got your email when you registered, but we'll make sure that we get all the information we need to send it to you. And Suzanne, actually, we should have asked you, tell us about this particular wine, if you'd be so kind.
Sorry, which wine? I didn't hear which one you were.
Yeah, no worries, no worries. The first one was the Uncharted Terroir Cayuga White.
So Cayuga is a grape that came out of the Cornell breeding program. So they cross varieties to try and get the best wine making characteristics of some of the European varieties with some of the ruggedness and resilience of some of the North American grape varieties. And so this particular cross was named after Cayuga Lake because it was adapted to grow well in the Finger Lakes. I think we've been growing it for probably more than the 40 years the winery's been around. I think my parents planted some in the 70s. This is, as far as we know, the first ever, generally Cayugas are made in sort of like a semi-dry style, maybe even a little bit sweeter. This, as far as we know, this is the first barrel-aged Cayuga White. It's very dry, and it spent quite a bit of time on its gross lees, so there's a lot of mouthfeel. So it's very interesting. I get a lot of grapefruit in flavors when I drink it, so it's quite an interesting wine.
Excellent. Bill W., we're sure you're going to enjoy it. And then Suzanne, since we got you, the Uncharted Terroir Valvin Muscat, the next wine up for the raffle or the sweepstakes or whatever you want to call it. Tell us about that one.
So similar to Cayuga, also another grape that came out of the Cornell breeding program. This is also very dry. When we launched this brand last year, this was the one that our ag commissioner for New York State, this was his favorite. It's a very floral grape, so very interesting, often done in sweeter styles as well. So people are having fun with this one. A lot of folks have never had a Valvin Muscat in a very dry style. So that's also a very cool wine.
And here we go. We're going to spin the wheel, and the winner is Raymond D. Congratulations, Raymond. Way to go. Way to go. So we will be actually sending you as well information that we need. Suzanne, I think you need an address, as well as making sure that everybody is over 18 or whatever the law is in New York State, right? So,
don't we wish? It's 21, Ron.
Is it 21? Yeah, well, Okay, well, hopefully Raymond E. is over 21. All right, last but not least, we have the third wine in the series, and that is the Novelty, Innovation, Change, New, Fresh, Unusual. If you would, Suzanne, please tell us about this one.
So this is totally different style than the Uncharted Terroir Cayuga, but made with the same grape. So also made with our certified organic Cayuga grapes. It's a semi-dry, so there's a little bit of residual sugar left. Just a delicious wine. It's a little on the sweeter side than I typically drink, but everyone has a different style, and depending on what you're eating, if you're having food with it, it's nice if you're eating something spicy to have a wine with a little more sugar. So this has been super popular, slightly sweet, bubbly wine. So more on the kind of Prosecco side of bubbly wines.
The Prosecco side. Here we go. Last but not least, the third and final drawing goes to Emily O, except Emily's not qualified. So Emily got disqualified. So sorry, Emily, we're removing you and we're doing it again. Here we go. Sorry, Emily is part of the family. So she was here, but she shouldn't have been on this list. So the winner is Raymond E. So wait, did he win too?
Yes, he's won one already.
He won.
He's disqualified as well.
Okay, sorry about that. I should have removed it. Well, actually, you got kind of. Well, actually, true. He got his chance of winning the first time. Okay, so last but not least, then. Sorry, Raymond, can't give you the two bottles, but last but not least is Steve D. Or Ted H. Ted H. Sorry, missed that for a second. So Ted, Thank you very much. Thank you, everybody, for joining in again. If you would send any additional questions that you might have, and really appreciate everybody coming. Suzanne Hunt and Mike Murphy, thank you guys so much. This was great. Really appreciate it. I'm sure we're going to have additional questions come your way over time, but Suzanne, especially, thank you, thank you, thank you. And Mike, great job, both of you guys. So have a great day, everyone.
Thanks,
Thank you
Ron.
all.
If you get tired of working on renewables, you can always go and be a game show host. Bye, guys. Thank you.
Yeah, my next colleague. Thanks, Suzanne. See you guys.